So there's one technique can integrate the tubing, the switching, and the centrifuge, metering, and mixing. We call it lab-on-a-disc. And this is that we integrate all the lab process. And when we rotate the disc, you can get everything done. So in the development process, we need to know what happened on the disc while it's rotating, right? So in this video, it's rotating, but we can still see the image. Why? Because we use a kind of specialized photography we call strobe photography. So we need to have a motor. The motor is synchronized with the trigger of flashlight and the camera. And when they synchronize, very precise, very well, and we can get something like this. So this is a camera shutter. It's match the frequency of the helicopter rotator. So you can see it's now rotating. It's like magic, but this science. Yeah. So this is a lab on this setup imaging. So we need circuit, the programming, optics, and then we can easily cost 3 months for master or PhD student start from scratch. And then we build the big system. Then we have a camera on top, and flashlight controller, and motor, and they all synchronize with a millisecond precision. So I have a different method. This is a spy camera. You can get available online. It's transfer image wirelessly, and it has some interface you can see on the phone or on PC. And wireless power. I think the new phones, they mostly have a wireless power, so we can just charge without plug anything. And then we can use the wireless power to power the camera, and the camera is fixed on top of the disk and rotating together with the disk. Takes less than 1 week, and we can have a higher performance. So this is the video. Shows you the camera is rotating together, and we can see the image on the disk while rotating. And no programming, no circuit design, no optics, only soldered 2 wires. And this is the video capture by the spy camera. So you can see the centrifuge progress of the E-cell. So the traditional method is there's a drawback that the temporal resolution is proportional spinning speed. So if spin faster, it takes more higher frequency of image. But if you spin slower, and we have a huge gap that we only take photo when the disc rotate and back to this position. So we don't know what happened here. But with the spy camera, we image every part while the disc is rotating. So we can do something like, we can image really fast happening event. So for example, this one video shows the 2 liquids mixed together really rapidly. So we have, the spy camera has a higher temporal resolution. We can see the process. This is not possible with a traditional setup. So we can discover new mixing patterns on the disk. Okay, so we combine the Blu-ray optics, but this time we'll only take out the objective. And then we can just put on top of the spy camera, and we can get micro size imaging resolution. So this is the world first microscope on the disk, imaging while rotating. So here's one video I show in the conference. You can have a look. Actually, I made that photo for that conference. I recycled that photo. Yeah. So I think we integrate everything, the cell culturing and also imaging. So I also integrate the drone and use a drone motor to drive the disc, because if we have something heavy, you need a higher torque. But the traditional motor is too heavy, and this Blu-ray drive motor is torque is too small, and the drone motor actually is quite efficient. So that's why I choose it. And as you can see, I use the drone motor and the spy camera and Arduino, build a small system. It can do the things exactly like the big one. So we can make it portable and to do the sample treatment outside the field, because only need a 5-volt power. Okay, so this is actually I put it outside in the booth, and you can see this is real-time image, and this is the disc is rotating.